Let's get ready to complete the square. I just completed this. I think math guys will love it. On our agenda, we're going to review perfect square trinomials. We'll complete the square when a is 1 and a is not 1. Let's get ready with your notes and a pencil. And take a look at these and think about what you notice. Maybe you noticed that these were all perfect squares. If we look at this, this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. And then how are those numbers related to the middle numbers? Well, 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, 6 to 12. They're all times 2. So these are examples of perfect square trinomials. And that's what we're going to try to do with the name of this strategy. It's called Complete the Square. We're going to try to make these perfect square trinomials so that we can then solve a quadratic. So if we follow that pattern, what's going to complete these? Well, 49 is 7 squared, so 7 times 2 is 14x. 81 is 9 squared, so 9 doubled is 18x. And we've completed the square. We have perfect square trinomials. So completing the square is a new way to solve quadratics. It will always work. You are making a perfect square trinomial in order to factor it. And the key piece is taking half of b and squaring it. So let's try. This is an example when a is 1, and you notice it's in standard form. So the first thing we want to do is I want to add 11 to the other side. When I do this, I'm going to have x squared plus 10x. I'm going to open a blank equals 11 and open a blank. And I still do this. I add the blank so that I remember if I'm adding a number to the left, I also have to remember to add it to the right to keep this to be a balanced equation. And here is where that half of b squared comes in. So 10 is my b, so I'm going to be adding 5 squared to both sides. And notice on the left side I wrote it as 5 squared, on the right side I wrote it as 25. And I purposely did that on the left side so it can just help me see it factoring a little bit more easily. So I'm going to take the square root of the first term, which is x, the sign of b. So notice this is always going to be plus because it's a number that's squared, so it's always going to be positive. But the sign of b may be addition or subtraction. That would carry down. So this is going to be plus 5 whole things squared. This left side is a perfect square trinomial, and all we've done is factored it. But what we've done in the bigger scheme is we did have an x squared and an x, and now I only have an x, so that's good news. 11 plus 25, I'm going to simplify that up to 36. And now I have the one side that's all squared, so we can undo that by square rooting. Square root both sides, and remember that plus or minus. So now I have x plus 5 equals plus or minus 6. One more step, we're trying to solve for x, so x equals negative 5 plus or minus 6. If you have actual numbers, you should go ahead and simplify that up. So negative 5 plus 6 is going to give me 1, and negative 5 minus 6 is going to give me negative 11. Those are my two solutions. Remember that they represent my x-intercepts. So you could pause here and write down your steps. You want to separate the constant, so you're adding that to the other side. You take half of b, square it, add it to both sides, factor the perfect square trinomial, simplify the other side, take the square root of both sides. Remember that plus or minus. That's what's going to get you your two answers. Simplify your radicals and then solve for x. Let's try to complete the square when a is 1. I want you to pause and try it, and then we'll go through it together. So first thing I'm going to do is subtract my 22 over and open my blanks. And I'm going to take half of b, which is my 8, so I'm going to add 4 to both sides, 4 squared. I'm going to factor the left, 2x plus 4, whole thing squared. I'm going to simplify up. Negative 22 plus 16 is negative 6. And now I'm going to take the square root of both sides. Did you notice this? We happen to run into a square root of a negative, so we will be dealing with an I along the way. Remember your plus or minus with your square root. So I have x plus 4 equals plus or minus I root 6. One more step, I have to subtract the 4. So x equals negative 4 plus or minus I root 6. I like to write the negative 4 in front, not after the 6, because sometimes it looks like it might get stuck under the square root sign. Now let's take a look at completing the square when a is not 1. So in this case, a is 2. And the thing you need to do is you need to remember to divide everything by a first, because we want a to be 1. So we're going to have x squared minus 7 over 2 x plus 5 over 2 equals 0. And I'm going to stay with fractions. You'll see it's going to be a little bit easier than going to decimals. I'm going to subtract the 5 halves over and open my blanks. And now I'm going to take half of 7 halves. So 7 halves times a half is 7 fourths. Notice this minus. I'm going to just leave that for the next step. So this is plus 7 fourths whole thing squared plus 7 fourths whole thing squared. Remember to square the bottom. So this becomes 49 sixteenths. This right here, this denominator, that's where a lot of kids make mistakes. They just forget to square that. On the left side, I have a perfect square trinomial. I have x minus 7 fourths, whole thing squared. And on the right side, I'm going to simplify, so I'm going to get a common denominator with that negative 5 halves. So that means 16, so I multiplied by 8, so I get negative 40 in my numerator, plus 49 over 16, 9 sixteenths. That's not so scary anymore. So that's going to equal 9 sixteenths. We're going to undo the square, so I'm going to take the square root with a plus or minus there. X minus 7 fourths equals, well, those are both perfect squares, so I can take the square root and I get plus or minus 3 fourths. Add the 7 fourths over, so 7 fourths plus or minus 3 fourths. And x equals 10 fourths, which we can simplify to 5 halves. And x equals 7 minus 3 is 4, so 4 fourths, which is 1. Those are our two x-intercepts. Here's our steps. Notice I kept them all the same, 1 through 8. This just has the added step at the very beginning, and you can't forget to do it. You have to divide everything by a first, and then you can move on with the complete the square process. So pause and give this a try. Did you remember to divide everything by 3? That should have been your first step. So I end up with x squared plus 10 thirds x minus 8 thirds equals 0. I'm going to add my 8 thirds and open my blank. And yes, it's a lot of fractions to deal with. So here I have my b value is 10 thirds. 10 thirds times 1/2 is 10/6, and that reduces, so 2 goes into both, so we have 5 thirds, and it should make sense that 5 thirds is half of 10 thirds. So I'm going to add 5 thirds squared to both sides, and on the left I'm going to factor, and I get x plus 5 thirds whole thing squared, and I'm going to simplify over here, so I have 8 thirds plus 25 ninths, so common denominator is 9, 24, and we get 49 ninths. I'm going to take the square root of both sides with a plus or minus, subtract the 5 thirds, so I get x equals negative 5 thirds plus or minus 7 thirds. So x equals 2 thirds, and x equals negative 12 thirds, which is negative 4. And you did it. You're on your way to completing the square. Good job.